Hey guys, this is our video going over the homework from the trig proofs lesson. So here we go. Number 1, the sine of theta cosecant of theta equals 1. Well, we need to draw our dashes through the equal sign. Let me zoom in a little bit. And obviously, because we have equals 1 on the right, we're going to need to work on the left. So I'm going to circle cosecant of theta because I can replace that with a basic identity. So I'm going to have sine theta times, I can replace cosecant with 1 over sine theta. And hey, the signs cancel, and I get it to equal 1, which matches. Woohoo! Number 2. Okay, so I have 1 plus tangent squared x over secant squared x equals 1. And I'm going to work on the left again, because I have more stuff. There's not much I could do with a 1. All right, so I'm looking at this and I'm like, I think we will be able to replace that. That looks like an identity. So I'm gonna go back to my notes. 1 plus tangent squared. Hey, 1 plus tangent squared equals secant squared. So I can replace the 1 plus tangent squared with secant squared. Oh, look at that. Secant squared over secant squared, this equals 1. Whoops. And we made it match. Whoops, I should point the arrow to the 1. Oh, that looks dumb. Whatever. You know what I meant. Yay. Number 3. So we have conjugates here. So I'm going to focus on the left-hand side. And I'm going to multiply that out. So cosecant theta times cosecant theta is cosecant squared theta. Cosecant times -1 is a negative cosecant theta. 1 times cosecant theta is a positive cosecant theta. And 1 times -1 is a -1. I ran out of room there. So the middle terms cancel, like I've told you back in the notes. And I've told you that before too when we factored and stuff. So cosecant squared theta minus 1 is what's left. And how can I make that look like cotangent squared theta? Cosecant squared theta minus 1. That seems highly familiar. I think this is an identity. Actually, I know it's an identity, but I'm just trying to play along. So cosecant squared theta minus 1. There's cosecant squared. And if I subtract 1, I'll get the cosecant squared x minus 1, and it'll equal cotangent squared x. So that's what I can replace it with. So this becomes cotangent squared theta. And hey, that's all I needed. And now it matches. Woohoo! Okay. Number 4. What side of the equation do I want to work on with this one? I think I want to work on the right this time because we've got conjugates here. So I'm going to have to get a common denominator, which means I'm going to have to multiply the conjugate top and bottom with this fraction and the conjugate of this one top and bottom on the second fraction. So the conjugate of 1 minus sine theta is 1 plus sine theta. So I'm going to multiply top and bottom by 1 plus sine theta. 1 plus sine theta. Okay. On this side, I'm going to multiply top and bottom by the conjugate of 1 plus sine theta, which is 1 minus sine theta. Okay. So since we're going to have 1 plus sine theta, 1 minus sine theta, 1 plus sine theta, 1 minus sine theta, for both of these, we'll have a common denominator. So I'm going to focus on the denominator first. So remember, the middle term cancels. So I'm going to skip writing the middle term this time since we know it's going to cancel. So 1 times 1 is 1. And we know that 1 times negative sine theta is negative sine theta. Sine theta times 1 is positive sine theta, so the sine thetas will cancel. And then sine theta times negative sine theta is negative sine squared theta. Okay. So that's the denominator. in the numerator, I have 1 times 1 plus sine theta. So I'm going to have a 1 plus sine theta. And for the other fraction, I'm going to have 1 times 1 minus sine theta. So I'm going to have plus 1 minus sine theta, because multiplying by 1 doesn't change it. All right, now I notice that I have a positive sine theta and a negative sine theta, so they're going to cancel each other out. And 1 plus 1 is 2. So I have 2 over 1 minus sine squared theta. And now I'm looking over at the left, and I'm like, okay, I need this to be 2 secant squared theta. So I got the 2. How can I make this a secant squared theta? Well, 1 minus sine squared theta should look highly familiar and suspicious. So I believe it is an identity. It's a big kahuna. So I need it to be 1 minus sine squared. So if I subtract sine squared from both sides, I'll get the 1 minus sine squared, and it will equal cosine squared. Okay, so I can replace this with 2 over cosine squared theta. Okay, and 2 over cosine squared theta, well, cosine squared I can replace with secant squared theta. So that works, and it matches. Okay. The secant squared theta is not in the denominator because cosine squared is in the denominator, and these are reciprocals of each other, so the other one will be in the numerator. Okay, in case you were wondering, because I can already hear questions coming up. Like, I can imagine that you guys are there and what kind of questions you would ask, so I try to make sure to cover all those that I think that you would ask. All right, number 5, this one, it's a little tricky, but it should have looked familiar because we have a difference of 2 perfect squares. So where's my pad of paper? When I say a difference of squares, I'm talking about something like x squared minus 4. When we would factor that, it would factor down to 2 binomial factors, x plus 2 and x minus 2, or vice versa. So that's what I mean when I'm talking about a difference of squares, and that looks like it. This looks like it too, but I need to pick a side, so I'm gonna pick that one with the bigger exponent. So I'm gonna dash through my equal sign. I'm gonna focus on the left, and I'm gonna go ahead and factor that. So when this factors down, because it's a difference of 2 perfect squares, just like x squared minus 4 is, it'll be cosine squared x, and then the other one will have a sine squared x, sine squared x, and one will have a plus in the middle, and one will have a minus in the middle. Okay. Well, I need it to be cosine squared x minus sine squared x. Can I replace one of these? Hey, isn't sine squared plus cosine squared equal to 1? That's our big kahuna identity. So this turns into a 1. So we're going to have 1 times cosine squared x minus sine squared x. And hey, that's the answer we're looking for. We got it to match. Okay. Number 6, 1 plus cotangent squared phi, this symbol, it's not a theta because theta has the line through the middle. This one has a line vertically through the top, so it's called phi, P-H-I. So 1 plus cotangent squared of phi over cotangent squared phi equals secant squared phi. All right. Again, I'm going to focus on the left because I noticed this bad boy up here, 1 plus cotangent squared. Should look highly familiar. 1 plus cotangent squared is equal to cosecant squared. So I can replace that with cosecant squared. So I'm going to have cosecant squared phi over cotangent squared phi. Okay, and I know that I can replace some things. So for instance, I can replace cosecant squared because cosecant is the same as 1 over sine. And I can replace cotangent squared because cotangent is cosine over sine. So I'm going to replace both of those things. So I'm going to have 1 over sine squared phi. That's what cosecant can convert to. Over, let me move this up so you guys can see. Over, in the denominator, I'm going to change cotangent squared to cosine squared phi over sine squared phi. You're probably like, oh, Mrs. Garcia, too many fraction bars. That's okay. What we're going to do is we're going to take the middle one and we're going to change it to the divide symbol. And you probably know where I'm going to go with that.
Me too.
So we're going to have in the numerator, it's 1 over sine squared phi divided by the denominator is cosine squared phi over sine squared phi. And dividing fractions, it's easy as pie. You flip the second and multiply. So sine squared phi times sine squared phi over cosine squared phi. And hey, the sine squareds cancel. So all I have left is 1 over cosine squared phi, and 1 over cosine turns into secant squared phi, which matches the right. So we did it. Okay. Now some of these steps in between you could have done in one instead of breaking it up into multiple steps. So Violet Princess Leia is trying to jump down and she cannot. She needs help. She's old. Oh, she did it. Well, as long as she doesn't break a hip, that's all that matters. All right, so this one equals 1. So we're going to work on the left-hand side, obviously, because there won't be a lot to do with a 1. And so now number 7 and number 5 kind of have the same feel to it because we had to factor number 5 to prove this one. We're also going to need to factor number 7. This ends up being a perfect square trinomial because the first term is a perfect square, the last term is a perfect square, and the middle term is the square of the first times square of the second times 2. It's doubled. And that is the properties of a perfect square trinomial. So, yeah. So this is going to factor down to 2 of the same factor. Okay. So it'll be secant squared x. This will be a secant squared x because that's secant squared times secant squared is how we get secant fourth. And then to get the tangent fourth, we need a tangent squared x times a tangent squared x. But because of this minus, both of these have to be minus. Now let's check it. Secant squared times secant squared is secant fourth. Secant squared times negative tangent squared is secant squared minus tangent squared, or sorry, it's negative secant squared tangent squared. Negative tangent squared times secant squared is another negative secant squared tangent squared, so that's 2 of these negative ones. And then negative tangent squared times negative tangent squared is positive tangent to the fourth. So it checks out. Always check your work before you finish it off, okay? And secant squared minus tangent squared, that should be familiar, and we've got 2 of them. So secant squared minus tangent squared. So I'm looking at the last identity there. If I subtract tangent squared from both sides, I will get secant squared minus tangent squared, and it equals 1. So I get to replace both of these with a 1. 1 times 1 is 1, and we get it to match the right-hand side. Boom shakalaka. So there we go, guys. That is all 7 problems in under 15 minutes. Hope this helped. Please let me know if it did help, and I'll see you guys in my next video. Have a good one.